This is lecture 33. This time I will show this demo, the streaming on the multicasting framework. This is the first solution. I will run this solution, polling and broadcasting solution. We have another solution. In the next time, I will explain the code first. Then I will show the demo. And we have explained the code for polling and broadcasting solution. So now we need to run this demo. Now before we start it, I need to introduce 8 rows. Maybe it's better for us to start from here. Okay, this is our server. Streaming. You can see here 2 solutions, right? 2 solutions, broadcast, unicast. We enter this directory. Here, the 8 folders on the broadcast directory. The first one is admin. Admin is in our case. At least until now, the administrator is responsible to shut down the system. The management task for administrator is not so difficult. Just shut down information. The second is child. Child is a node in the multicasting framework. And the clan is identical to the user. This is the user on CS clan. This is identical too. They're different name and they're same. Equivalent. They are really equivalent to each other. The next, publisher, right? Publisher. And pub sub server. Okay, this is the pub sub server. And the next is registry. Registry is this one. We see it a lot of times. And the root is the critical, because it's all the data is start from here, right? For the multicasting, the stream start from here. All the data should start from the root. Okay, this is the root. Root is the topmost distributed node in the multicasting framework. And subscriber. Yeah, this is subscriber. Okay, the 8 rows. So this system is more complete than what we have seen before. So because right now we have 8 rows, 8 folders, or 8 directories for this project, for this demo. So there, how to run such a system. Here I introduce you how to do that. This is steps. First, we need to start the registry server, right? Okay, because this is my laptop. The screen is small, so I have another screen, but you cannot see it. So okay, you can see this terminal, right? I can drag this terminal from another screen. My laptop have 2 screens, but what you can see is only one. So if there's some terminals in another screen, so if needed, I will drag them in, and if they are not needed, I will drag them out from the main screen. You'll see. Okay, so the first step, we need to start registry server. It's easy to understand, right? Because the registry server is most important for scalable system. It has explained that many times. Okay, let us start the registry server. First, this is the first step. Okay, start it. That's the same. We already run it. We have seen such a Registry server. We have seen such demo many times. So now we do not need to see it. So just drag them out from the main screen. Next, next, we need to start the PUB subserver. This is the next one. Okay, why do we need to do that? Can we start the children first? No. In our case, you can see here, this is the children. This is the children. This is the code with, oh, no, not this one. This is for unicast. Let us see this one. This is the broadcast children, right? So for this case, the child, all the children in the multicasting framework need to know the pub sub address. Things the children in the multicasting work need to access the pub sub server to get the subscriber information. When new data need to broadcast to subscribers, so the pub subscriber need to be started first. Need to start it before child, before the children of the multicasting framework. So next we need start. Okay, this is another terminal. Okay, let us start the pub server, pub sub server. Okay, pub sub server. Okay, let's start it. Okay, you can see pub sub server is implemented with peer, so some registry information is sent to the registry server. Okay, so now we just drag them out because we need to run some other applications. Okay, now what is next? Next one is children. Start children, that means because we have multicasting framework, the children should be started, and all the children started before the root. This is the strict order for the multicasting framework. Maybe we can, in the later classes, we can change the order, but for at this time, the children should be started. All the children should be started before the root. So we start. Okay. We start the children. We can open some terminals, start multiple children, maybe of at least 2, 2, 3, 4, 6, 7, 6. You can determine as you like. Actually, in the practice, the number of children can be unlimited. But this time, because we just show a demo, so we just open maybe 4. Okay, this is the first one. Okay, we see such a display, such information before, right? Okay, this is the first one. We open new terminal. Okay. Open. Start. This is the second one. Second one. Started. Okay. As a multicasting framework, it's necessary for us open multiple children. Okay. This is the third one. Okay. We got another one. The fourth one. Starting, this is the fourth one. Okay. Put it into another screen. Okay. So next, what else? Can follow this slide. Next, we can start the root. Think the multicasting framework need to be the all the children. We got four children, so all the children is starting. So this is one of the children. Now we need to start the root. So when the root is started, the children should get information, get a root IP address. We see such a demo before, right? Okay, so 4 children. The root has 4 children to create a tree, the multicasting hierarchical structure. Okay. Next, what else? Next step, we need to start the publisher. Publisher is a data source, right? The stream. The stream is the data is originated from the publisher. Okay, start publisher. This is a terminal for the pub sub server. When the publisher is started, it need to register on the pub sub server for the data. It will post to the multicasting framework. Okay, so for example, this is the name of the publisher, A3A, right? AAA. This is the name. The publisher is implemented with a CS clan, right? So it's easy. Next. So it's not necessary. It's a clan, so it's not necessary to register on the register server. So we do not need to see that screen. We just want to see this one, pub sub server. Okay, this is a topic. So you can see some registry information is displayed on the pub sub server. Okay, how many posts? What does it mean? Since they're streamed, so that means a high volume data should be broadcast or multicast into the multicasting framework, into the streaming framework. So how many posts? If the number of the posts is small, it's not necessary for us to implement a streaming framework because the data is huge. So that's why we need to implement such a framework. So that 1,000 piece of data will be sent to the streaming framework one by one. There's some delay between each of them, maybe 2 seconds. Okay, press it. Okay, you can see here, this is data to be sent. Generational, Joy, BMDFM, Julia, baby script, a lot of information is sent to the multicasting framework. Let us take a look at this is the children. You can say all the children got the same information because this is the broadcast. This is another children. All the children got the same data. Okay, this is third one. This is fourth one. Okay. The fourth one, right? It's a broadcasting. All the data is originated from the publisher and post all the data to the root, and the root perform broadcasting within the broadcasting framework. Okay, so you can see the stream is flow within the broadcasting framework, right? So next, what else? Subscriber means somebody are interested in the data flow, interested in the stream. So we can move out those children's terminal, since we need to see other process. Okay, here we open another terminal. Okay, this one. Subscriber, okay. Okay, this is subscriber, right? Run it. Tell me your name as subscriber. Subscriber is implement with peer, so each peer need to have a name. So we need to input one name, star. Okay. Actually, it's a peer, so it need to register on the registry server. So we don't need you can easily understand, right? That's easy to understand. But here, the information is displayed here. One piece of additional information. This is a register string. Registry. That means because this is subscriber, right? The subscriber already registered. The subscriber already registered. No, the publisher already registered on the pub subserver about the data it will post. So this subscriber are interested in that. But you can see here a lot of subscriber requests are received by the pub subserver. This is the polling. Since each time one of the children in the multicasting framework will be selected to send the stream to the potential subscriber. So when new data is received, for example, this is one of the children, right? If this children is selected, it will access this pub subserver to get the information about subscribers. So you can say it's like polling, right? The polling, we have seen polling before in the MNCS chatting system. That is the similar thing. Okay, when new data is received, one of the children will access the pub subserver to get subscriber information. However, at this time, one subscriber is already started. However, this subscriber has not tell the pub subserver the data, the stream, which stream it interested. Has not done that. So no data is received. Now we can tell the subscriber, tell the pub subserver the stream that interested. Now in such a system, only one stream exists. The stream is AAA. The author, the publisher name is AAA, is AAA. And the topic, the triple X. Okay, you can see data receive, streaming, data is received, streaming, data is received. That's great, okay? Things this time, the subscriber, you can see the subscriber send the subscribe stream request to the pub sub server, and that means the subscriber already tell the pub sub server the stream that it interest. Then if the stream exists, one of the child in the multicasting framework will send such data through multi-broadcasting to the subscriber. Now, because only one subscriber exists, so this broadcasting is easy, right? It's easy. So it's necessary. It's better for us to create another subscriber. Okay. Oh, maybe this time. Okay, we can create. Move out this children terminal and let us start another publisher. Okay, let us take a look at this one. It's necessary for before that we can take a look at this one. This is a registry server. You can see the registry server is busy. That is different from what we have seen before in the previous projects. In the previous classes, we see some projects, but in those projects, the registry server, when we use that server, there's no such information, right? The registry server is not so busy. The registry server, after the IP address is obtained from the registry server at the beginning of the system started. It's not necessary for us to access that server so frequently, because in this time, this design is not good enough. We have to access the registry server. We have to get IP address of subscriber, all the subscribers, to perform broadcasting from 100 child to all the subscribers. Because we want to do that, this design is not good. You can see the registry server is a little bit busy, right? So it's not good. Okay, we have another design. Okay, let us start another subscriber on the publisher. Okay, this one maybe triple B. The topic is triple Y. This is a post. A large number of posts need to be published. Okay. Next. Now there are two streams. You can see there is another ad, right? Two stream or exist within the streaming framework. Okay, let us continue the demo. Subscriber, okay. Start another subscriber. So two subscribers exist at this time. think we have only one server to run all the processes, so it becomes slow, little bit slow. Okay, started. Let's name it. This is peer. You need to register to the registry. You can see, right? It's registered. Okay, next. You can see after this subscriber register on the register server, two string. This one triple B, this one triple A, right? Two streams are available. So maybe this one, this subscriber, this is the author is right. It is slow. It's a bit slow. Okay. We need to wait. Okay. It's slow. Sorry. Okay. So this server or this subscriber will get information AAA access from this stream will flow to this subscriber. The BBB string is available, right, on this server, on this subscriber. Okay. And what else we can do? Next. This is the pub subserver is busy, right? Because of polling. Okay, let us show the last one, the clan. This is the clan. Okay, the clan is the user. User need to interact with these two servers. Okay, two subscribers. Okay, before that we can show another one, another demo. We can press enter. You can see there is a information display. There are question. Do you want to continue this string? We can press N. Then this server, this subscriber can make another selection. For example, BBB, YYY. Okay, then it gets such information, right? Get new streams. New stream is obtained. The same thing. We can do that here. Okay, maybe this one interesting AAA and triple X. Okay. Then it gets another string. Okay, that's great. Okay, next we can okay, we can maybe this one, this clan interest AAA as XXX triple X search query. It must interact with this subscriber because this subscriber has such string, right? And then we search this one, Java. Oh, we got some information, right? We got this information. Continue same, yes. We can search again this one. Oh, no such information. Continue. Yes, we got some information from the subscriber. No. Maybe this time one of the subscriber will be selected if multiple subscriber available, right? Not only two subscribers, but the same thing. Java. Oh, got a lot of information about Java on this string, from this string. Julia. Oh, sorry. Okay. And what else? Swift. Continue. Swift. Okay. A lot of information is obtained. What else we can show here? Maybe. Okay, that's a demo. I think maybe we can. That's enough to show that's such a system. Maybe if you are interested, you can open another client. Maybe you can open another subscriber, and you can start more publisher, and that is fine, no problem. But I think that's enough to show such a system, right? The demo is successful. Okay, let us take a look at a two registry process. This is the pub sub server. This is a registry server. And if maybe you are interested in the children, right? This is root. This is root. Root is basis perform broadcasting. It's a subscriber. It's a subscriber. Another subscriber. Okay. This is another children. Broadcasting is performed among all the children. Okay, I think this is a successful demo, but we still have another task need to do. At this time, we need to stop the server, stop the system. So first, we need to stop the client. Stop the client. Client is here, right? This is the client. So first we need to stop the client. Q. Okay, stop it. It's slow, so I don't want to. Oh. I think. Okay. Because the server is busy, we run a lot of process. Okay, this one is stopped. Next, what else we can do? Stop the subscriber. Subscriber. Q. And subscriber is stopped. When subscriber is stopped, because subscriber is a peer, is implemented as peer, so some remote, some information, right? Some information need to remove from the register server. This is the pub. So you can see unsubscribed stream notification is received by pub sub server. Okay, there's still another subscriber. Let us remove it. Q. Okay, so next, what else we can do? Let us take like a slide. Publisher should be, the third one should stop the publisher. The publisher is implements a client. So it's according to the code, you can take a look at the code. Publisher is stopped only all the posts is sent to it finished, then this information will be displayed, whether to continue or not. However, because the number of the posts is 1000, it takes a long time to finish sending all the data. So to simplify this procedure, I just press Ctrl C to stop the publisher. It's not good enough, right? But things it's not. It doesn't matter. I already show the features, the primary features of the system. So it's not good, but you need to remember that, okay? Ctrl C. If you create a practical system, it's not good. Stop one system by Ctrl C. Stop another publisher. Okay, so no information, right? So this is you can see the root stop broadcasting because no data is available. Stream is stopped. Data source is not available. Data sources are terminated. You can see all the children stop work. All the children stop working. Okay, this is another children. Okay, another children. No information displayed anymore. Stream is terminated. Next, we need to stop the children with admin, right? We see that before. Okay, let us enter the directory. We need to stop all the children's. We move some children terminal. Move all the children terminal into the main screen, so you can see whether the children are terminated successful or not. Okay, let us start the main. Okay, second option. Okay, all the children stop. Successful. Stopping a system is very important for a large-scale system because we need to keep all resources, collect all resources, and keep the data safe before the system is stopped. Okay, next. What else? We need to stop the root. Root is here. This is root. This is the root. No. A lot of information, right? Root is stop. That's correct. Okay, next. We need to stop the pub sub server. Okay. This is the terminal for the pub sub server, right? Option false. Okay. Next, the last one we need to stop is the registry server. Okay. Next, the last one. Okay, so this is a demo for the polling broadcasting solution. Such a solution has some advantage and disadvantage. We talked that issues before. Okay, next we will explain another one, and this is based on forwarding and unicasting, and then we also need to show the demo after explaining the code. Okay, if you have any questions, just letting me know. That's all for today. See you next time. Thank you so much.